When I said that using the simplex algorithm was really the last thing that you needed to know, I'm not making that up. You'll see that today when we deal with multiple optimal solutions. We've already established that using simplex algorithm, which is finding the corners and then doing that little table and finding the minimum and the maximum, we can find the optimal solution to give you a scenario at the vertices. But sometimes when you start doing these questions in 2C.3, you're going to notice that two of your vertices give the same optimal solution. But those aren't the only optimal solutions. So how do you deal with the multiple optimal solutions? Can you please get this rectangle down? Step 1, you do the simplex algorithm as normal. But what is different? When you do your vertex objective function table, you're going to notice that there's two optimal solutions that have the same value. Once you have that, you identify those corners on your graph and look at the line between those two corners. And then along that line, you look at each whole number point along the line between those two vertices. Every whole number point along that line is also an optimal solution. That's gobbledygook right now. You'll see what I mean when we look at Josiah Langdon James's example again with slightly different prices. So can you get steps 1 to 5 down, please? Did I get all your SACE numbers right? Make sure you check the PDF. See how this goes. We're using that same exact situation with Power Boost and Super Health that we used last time. So I'll give you that option. What you could do is if you have different coloured pen, let's say red or something, you could add that to the existing graph, but I'll also give you time to get the feasible region down again. Does that make sense what I'm saying there? You've already got this example in your book somewhere. Do you remember that? All right, I'm going to change the name slightly. Okay. That example is already drawn and it took you a while. What this multiple optimal solutions is about is there's one change. The only change that I've made is the objective function is different. Josiah's favourite supplements are on clearance. Power Boost is now $1 each. and super health is $2. So if you wanted to, in pen, on the existing graph that you've got from the starter simplex algorithm, if you wanted to say anything in red is for multiple optimal solutions, that'll save you some time, okay? But you'll have time to get this full example done anyway. So if you want to write all that down, that's fine, you've already got it. What is different is the objective function is now 1x plus 2y. It's cheaper. And that's going to make our results slightly different. Okay? I'm going to scroll down so that you can see the exemplar. We're still finding the optimal solution. Next, we're going to show you the graph that we've got, that we're going to do the maths on. So this is what you have from last time, is this thing. Right? The only difference is the objective function now is 1x plus 2y. We're pretending that you approached this question from scratch and you did all that other crap, okay? We've practiced that over and over. So what I want to show you is how is it different when it's multiple optimal solutions. So at this point, if I've drawn this, have I labelled the lines? Have I labelled them? Have I shaded the simplex? Is there any labelling that's missing? Have I told you what the x-axis is and what the y-axis is yet? No? So can someone tell me what the x-axis represented? Yep, number of power, no, not Bauer, power boost, and the y was number of super health. There's something else missing. Yep, I haven't identified the corners yet. See, this is no different yet. We're doing the exact same thing as before. So what is the coordinates of this vertex? 8, 3. This vertex, someone else please. Yep, 4, 5. And then this one here. 3, 8. So at this point, what do I draw up? Something with 2 columns. So the table, what's on the left? Vertex. What's on the right? Objective function. Func. And what was the objective function now that it's on clearance? It's slightly cheaper. Now it's 1x plus 2y is the cost of purchasing these things. Because it's the simplex function, simplex algorithm, I needed to try those 3 corners. So I'm going to try 3, 8. I'm going to try 4, 5. And I'm going to try 8, 3. 1 lot of 3 plus 2 lots of 8. 3 plus 16 is $19. 1 lot of 4 plus 2 lots of 5. What's that going to be? 14. And 1 lot of 8 plus 3 lots of 2. 2 times by 3. 8 plus 6, what does that come to? Good. So in all the exercises that you've done before, there would only be one of these that's the best. How many are the best now? 2. There's 2. So how is multiple optimal solutions different? Put a star next to both. You've identified that there's 2 possible optimal solutions, but that's not the end of it. Go to the steps, and what does it say? Identify the 2 vertices on your graph and observe the line between those 2 vertices. So what are my 2 vertices that I've identified are? Good. So I'm looking here. And what? 8, 3 and 4, 5. Not 3, 8. Is there a line between those 2 dots? So if you want to, you can highlight that. I'm looking at this line here. If you look at that graph closely, is there a whole number point somewhere along that line? Is that whole number point here? No, that's like half of a thing. Is that a whole number point there? Yes. So that actually, the reason why you need to check is that is also an optimal solution. Let me prove it to you. So you told me, what was it, 6, 4? If I chuck that here, 6, 4, what's one lot of 6 plus 2 lots of 4? 6 plus 8, also 14. So what's multiple optimal solutions? You're going to have 2 corners. So find those corners. Look at the line between those two. And any time that it goes over a grid line, that's also an optimal solution. Okay? That's the only difference with this. So therefore, what are the optimal solutions? 4 power, was it power boost? 4 power boost and 5 super health. 8 power boost and 3 super health. And the one in the middle, 6 power boost and 4 super health are optimal at how much does that cost him? Those 3 possible solutions. $14. $14. That's multiple optimal solutions for you. So I'll stop the recording now.